Hello, this is Chris, and today on Cozy Fabrications, we're going to be upgrading the nozzle on our Ender 5 3D printer. Let's go. So first of all, why would you want to upgrade the nozzle that came with your 3D printer? Well, the nozzles that come on your 3D printer are typically made of brass. Brass is not a hardened metal, and it's not always the best metal for doing the job of 3D printing. There are a lot of companies today that have taken nozzles to the next level and have a much better solution. So first of all, the brass nozzle that comes in your 3D printer is not a hardened metal. It is a softer metal, and so if you try to print any of the more abrasive filaments, if you try to print the glow-in-the-dark filament, if you try to print the carbon fiber filaments, any of the glass-filled filaments, those are actually going to wear out that nozzle, and depending on the abrasiveness, it could happen quickly, it could happen over time, but that 0.4 millimeter default nozzle size is going to wear out over time, and it's going to get bigger and bigger, and as your nozzle ages, your prints are going to continue to get worse if you continue printing with those filaments. Second of all, some of the newer nozzles that are coming out have better materials. They're harder, they have better thermal conductivity, so they're going to produce better prints overall because more of the heat is actually going to be getting to the filament as it's melting. Third point, a lot of these new nozzles, both coming from companies like Performance 3D, which I'm going to be talking about today, and companies like E3D, they have new coatings on these nozzles. The coatings provide, again, additional hardness to the nozzle, but they also are non-stick. If you've ever seen a standard nozzle, after you've been printing for even a short period of time, the filament's going to stick to that nozzle, and as it sticks to that nozzle, it's going to gunk it up, and then even more filament's going to continue to stick to that nozzle. You can clean it, of course, but this is a sort of a preventative measure that you can have built into your nozzle. Makes it easier to clean, and just makes the printing process easier and less messy. So I'm about to do a test print with my existing nozzle. This is the brass nozzle that came with my Ender 5, and we're going to use that initial test print to compare what the new print looks like. See if there's any differences. There may be, there may not be. Again, I haven't printed it yet. We're going to find out after the process is complete. For this test print, I'm going to be using a Sir Layersalot model from MakerBox. While that test print's going, I'm going to talk about Performance 3D, who is the company that I got the nozzle from today. So now that the test print's going on the Ender 5 with the brass nozzle, let's talk about the replacement nozzle I'm going to be using. It's from a company called Performance 3D, and first of all, they did not sponsor this video. I'm endorsing their product because it's a product that I purchased and I really like. I've also found that they don't have a lot of press currently in the community, and I'd like to showcase their product here. They currently offer 3 different models of their nozzles. The Elite series, which is a brass nozzle made out of 360 brass. They have the Apollo series, which is made out of 7075 aircraft aluminum. And then there's the Hercules series, which is made out of A2 tool steel. That represents 3 characteristics for nozzles. The brass is just slightly harder than your standard brass. The aircraft aluminum is going to have a higher hardness than the brass. It's also going to have a better thermal conductivity than brass. But then you've got the Hercules series with that hardened tool steel, which is going to have a much higher durability for people that print with more of the abrasive filaments all the time, not just casually. What really sets all of their nozzles apart, though, is that they use a special coating. They've labeled it DuraPlate 3D. This is a common coating used in the aerospace and injection molding industry, and what it does, it improves the friction and the lubrication of the actual part. It also adds a high hardness to the part. You should end up with a nozzle or a heat break that actually has a coating on it that keeps the filament from sticking to it. It'll make it easier to clean. It'll make the prints come out cleaner when the nozzle actually comes away from the print, like in a retraction or a travel. It should actually produce a cleaner break for that. So When I went to choose mine, I don't print with the abrasive filaments all of the time, and so I didn't think I needed the Hercules nozzle. Plus the Apollo series, which uses the aluminum, has a much better thermal conductivity. So I went with the Apollo series for this printer. You're going to see it close up in some of the shots while I'm doing the upgrade, and then you'll be able to compare the print quality, if there's any difference, to the brass nozzle. And later in this video, wait till the end, and I've already talked to Performance 3D, and they've given me a coupon code you can use on their website for 15% off your purchase if you decide to go with them as well. So next, let's move over to, once this print is done, we'll move to the upgrade process for the nozzle. So the test print with the brass nozzle is complete now, so let's go ahead and take a look at upgrading the nozzle and which tools we'll need. So right here on the table, various tools that we might need for this job. And so what we've got pliers and wrenches to get off the old nozzle to put on the new one. We have knives and clippers and pliers to get off the old cotton insulation. And while we're at it, we're also going to install a new silicone sock to replace that old cotton one it comes with. We also have some compressed air to clean off the wheels and any of the dirt and dust on the fans and inside the fan shroud. So let's take a look at the process. The first thing you need to do when you go to replace your nozzle, of course, is to remove the filament from your nozzle. So we need to go into the menu, go to Control, Temperature, and then raise the nozzle temperature to whatever the melting point of your filament is. For this filament, 200°C will be fine. After it heats up, we'll use a push-pull to get the nozzle clear. Once the nozzle's been cleared, then it's safe to remove the fan shroud. If you remove the fan shroud before you remove the filament, you actually may have heat creep melt some of the filament that you don't want to get stuck into your heatsink. So let's go ahead and remove this. This is the original Allen wrench that came with the printer. There's two screws that you're going to need to remove. One of them is on the left side of the shroud and the other one's on the top. And at this point, the printer is still heated up because we actually are going to need that hot in order to get that old nozzle off. Just be careful not to touch anything hot. It's a good time to remind you that this entire area is hot. It is heated up to melt the filament, and if you touch anything, you can have some serious burns. Kids, get your parents' permission. So here we are with the fan shroud out of the way. First thing we're going to want to do, use our compressed air. Let's get everything blown off that's under here. Now's a good time to clean up. Clean off the fans. With the fans while they're running. Everything run a lot quieter once you get them cleaned off. Now, depending on how gunked up your nozzle has gotten, this could be difficult. You may have to bring out some different tools if it doesn't want to come off. There we go. So, different tool, no problem. Then, for ease of removing, I'm actually going to use this. There we go. Comes off. Still has some filament inside. If you take a piece of filament that you have, actually stick it in here, get it to attach, and then if you grab it here, you may be able to pull out what's left in there. Just like that. And now you have a clean nozzle. And set that down on some surface that won't be damaged by the heat. At this point, we're going to try to remove the old cotton insulation because we've got the new sock that we want to put on there instead. That's easier to remove and easier to clean than this cotton insulation is. Taking my utility knife, I'm going to cut across the top here because this tape goes all the way around. And I guarantee you mine is gunked up because I've had an overflow or two. So hopefully it's mainly stuck to the cotton and it won't be a big deal to clean it off. And don't use your fingers for any of this. Everything around this hot end right now is hot. I'm going to pull this off. Some of that plastic's falling with it, which is what I was hoping for. And there we go. This point, you notice there's still a lot of gunk on my hot end here. I'm going to use a series of different things to try to clean this off before I put the sock back on it. We can try to scrape it with the blade, see how much that comes off. Notice this brown paper here. That comes off with just the tip of my knife. And if that's all there is to it, that's not too bad. This is an all cotton rag. It shouldn't burn, and as long as you've got enough layers between you and the hot end, you should be fine. Just sort of polishes it up and gets the last bit of surface stuff off. And once you have all that cleaned off, there's one thing you need to do, and this is an important step. If you don't do this, you could end up leaking filament all over your hot end, and it could really cause you a mess to clean up later. So I have put a little clamp in here. Yours probably won't have that. Pull that off. And then we're going to pull out the Bowden tube. And if yours is doing what mine is doing and it will not pull out, then what you're going to have to do is take your pliers and actually unscrew this from here. At this point, it's up to you. You could go ahead and cool the hot end down. There's no real reason to. It would just be for safety. But if you do this carefully, at the top of this heat sink, it shouldn't be too hot to touch. But again, use caution. If you're doing what I'm doing right now, I'm not being burned. Once that's out, that will pull out. Right there is why this wasn't coming off. If you notice, there's still some filament stuck in the end of that tube. At this point, you may want to do what I'm about to do and snip that off with a sharp knife. That amount shouldn't really change the length of the tube in terms of printing, but make sure that that's 100% straight and clean. If it's not, again, you may have a leak down the road. And make sure it's flat. Now when you're ready to insert the new nozzle, and like I said, this is the one from Performance 3D, this is going to fit into a 7mm socket wrench. And in order to put the nozzle in this for reloading, I take it and take 2 M4 nuts and place those into the socket. And then your nozzle won't go all the way down, and you can use that to load without any problems. And that's the easiest way to do this. Okay? Now when you're ready to tighten, once you get it all the way in, back it off just a little bit. So once you have that nozzle inserted and backed off, we're going to reinsert the adapter if you had to take it out. I'm going to tighten that in just a little bit. Now we're going to reinsert the tube all the way down until it touches the base of that nozzle. Now we're actually going to tighten up that nozzle, which will make a tight seal now against that tube to prevent leaking in the future. And there we go. Everything should be tightened together. Now at this point, before you install the sock on the hot end, you're going to need to cool down the printer. I would not install the sock safely without it. So cool down the printer, that's under the prepare menu, and once it's cooled down, then you can go for this step. So this sock is installed. The one I have has a CR on this side for Creality. This is going to come in from the side, or actually it's going to come in from the bottom, and the open side will be towards where the wiring is. Again, do this without heat and you won't burn yourself. Again, it should slide on there. All the sides of the sock should pop into place. And this should provide something that's removable and replaceable without the cutting and everything that you had to do with the cotton sock. the cotton insulation. And that fits perfectly around this heating block. Now we can reattach the fan shroud. When reattaching the fan shroud, we're going to want to drop the screw and lose it, and then go looking for it, and then find it. Alright, I gave up on the Allen wrench for reattaching this. So when we're attaching it, I recommend having some better tools. And then once you have the better tools, attach the top one first, screw that in. Don't tighten it up until you get the side one on. And then we're going to put this one here. Now we can tighten them both up. And now it's time to level the bed, because we've installed a new nozzle which has a different height than our old one, and then we can go to our test print. Make sure that when you go to level the bed that you first lower it, because you don't want your nozzle that you haven't tested yet to hit it. And then when you auto home, you won't have to worry about, you know, damaging your glass or whatever print surface you have. Alright, we're all leveled up. Time for the test print. Alright, so our two Layersalot are complete. Let's take a look at them. I will make sure you guys get a close-up as I look at these. These are both printed in push plastic PLA. This was something that I received in my maker box. And so they're exactly the same filament, just a different color, so I could keep track of which was which. The green is from the brass nozzle, and the blue is from the new aluminum nozzle. Again, I don't notice a huge difference in the stringing. In fact, in between the shield and the sword, it's about the same. For some reason around the helmet, the aluminum nozzle actually has a little bit more coming out from it. If you notice, there is quite a bit of artifacts on the sword. Those little nubs are actually from the time-lapse process, so I need to work on those settings. Those are actually not artifacts from the printer. So, given the fact that everything else being equal, let's take a look at the actual layering and the line quality. And I think you'll notice on the blueprint, even though the extrusion multipliers were exactly the same on these in terms of the flow rate, the layer lines are almost completely gone in the blue model as opposed to the green. It's visible on the shield, it's visible in the middle of the cape. It's definitely almost all over the model, to be honest. So I definitely see a huge quality, given that all things being equal, these are printed in the same sort of plastic and on the same printer. So really impressed with the quality overall. Any other quality artifacts, I believe I can dial in just by changing my settings in my slicer. I hope you found this walkthrough useful. I hope you found some of the information I was able to share about the nozzles of this printer and about the process of changing out and cleaning your existing nozzle. I hope you found that helpful. As I mentioned, end of the video here, I've got a special code for you. Go to p3-d.com, check out all of their products. If you type in the code KERSEY15, you'll get 15% off that order. None of that is a kickback for me. That is just for me helping out the company. And I think they're a great company. I think they have great products. If you enjoyed this video, please like it. Please leave me a comment. Let me know about what you thought about this upgrade. If you have any questions about the process, or if you have a recommendation on a future video. If you haven't already, please subscribe to this channel. I've got a lot more content coming. Hit the bell if you'd like to be notified as soon as I post new content. And finally, if you are interested in any of the models or any of the products I used in this video, you'll find a link to them down in the description below. Thanks again for joining me here on Kersey Fabrications. If you enjoyed this episode, like, subscribe, share, do things, I don't know, rub on your computer real nicely.
What?